Hello there everyone, my name is Jared Morris and I'm excited to share a tutorial regarding the Snap and Snapu software. To start, I wanted to give a little outline of what we're going to talk about today, including the overview of the Snap software and the design of the software, why the software was created, and then we're going to talk about selecting the data, installing the software Snap, and then installing the plugin Snapu. Then we're going to talk about downloading the data. Then we're going to basically prepare the DEM of radar data within the Snap software. So, SNAP stands for Sentinel Application Platform. You can see on the screen here that there are a number of basic functions, including opening images and gathering pixel information. And the best part about this software is that it's open source, so it's free to use to anyone across the world as long as you have access to internet to download the software. So Snap was first established in 2014. The application was made to process data from Sentinel satellites. And to create this application, they utilized both the Beam and the Nest softwares. As you can see, the Beam software was made in 2002, and it was the standard for optical sensors on NVSat. And Nest was made in 2008, which is a toolbox on top of Beam. So they utilized both the Beam and Nest softwares to establish this Snap software to analyze and process information of Sentinel data. So there are three pretty large toolboxes that are available: Sentinel-1 toolbox, Sentinel-2 toolbox, and Sentinel-3 toolbox. These different toolboxes run through different locations all across the world: Canada, France, Romania, and Germany. And these toolboxes allow us to do a couple of different things within the Snap software. We see here that the three different toolboxes can be installed and utilized to generate different things that we're looking for, including different add-ons and different ways to explore data. So then after that, we of course have all of these other things that we see on the screen, and that really just shows us that there are a number of different ways that we can use Snap with different programs, including Python and Java. Here we have a number of different tutorials that are available to all of us that we can utilize to more easily understand how the Snap software works and how to move data around, view data differently, and analyze data within the Snap software using different toolboxes. One big thing I want to take a second to approach is showing you all the forum option, because the forum is a wonderful way for us to have questions answered and take a look at what problems and difficulties and challenges that people might have faced previously that already have answers to us, which can help us when we're looking at radar data from Sentinel. So to get started, to install Snap, going to the step.esa.int to the main download, selecting the Windows 64-bit of Sentinel toolboxes. This will just ensure us that we have as many possibilities as we can for viewing Sentinel data, and using Sentinel toolbox is the only thing crucial for this specific tutorial, but you could of course download with all toolboxes if you are potentially interested in utilizing every single opportunity that Snap has for us. And so after we click the main download, we want to make sure we save it in our Windows C or Windows D drive, as long as we know where it's being saved, and we name a file Snap and select an entry, enter that main download into the Snap folder. So after we've downloaded Snap, we have to install it, and here we have a number of different steps, starting from our main interface saying next, then accepting the licensing agreement. Then when we get to the Snap user data interface, we want to say yes, try deleting all Snap user data. As long as we haven't used Snap previously, this is the one we want to select to make sure that it's clear and it's basically just reset from anything that might have been done in the past. Then we need to select our destination directory and click our Windows C or D drive, respectively, choosing the one that we've chose previously where we've downloaded the data into that Snap file folder. So first, we're now going to generate that new folder if we haven't already and name it Snap. That's our destination directory. After we've selected it, we can hit next, and then we get to the select components section, and we really only want the Sentinel 1, 2, and 3 toolboxes installed. This interface, this image here, is actually of all toolboxes downloaded Snap application, but if you downloaded just the Sentinel toolboxes application, you won't have any of these options. As long as you have Sentinel 1, 2, and 3 toolboxes selected, that's all you really need. Number 6 is really important. You want to unselect the Create and Start menu folder. We've tried a number of different times to understand why we need to unselect it, but we know that if you do not unselect it, then you won't actually effectively install the application. And then number 8 is a really awesome opportunity if you are interested in using Python with the Snap installer, the Snap application. But for our purposes today, we don't necessarily need to, so we can uncheck Configure Snap for use with Python and then hit Next. After that, it's going to start to load. So after we've gotten it to load up, then we're going to want to just hit Next and make sure those two are already checked. And then after it's done that, we can click the Finish button and we'll be opened to the Snap application and ready to be used. So now that our Snap application is installed, we now need to go and collect the data from Copernicus, which is the Sentinel interface to grab Sentinel data offline, following the link right above in this page. We can take a couple of seconds here and just take a look at all of the different options that the Copernicus interface gives us. We can see there's an advanced search, the full text bar, the save search, and a number of different opportunities for us to investigate. Just take some time and explore the Copernicus Open Access Hub. This interface is extremely easy to use and very similar to USGS Earth Explorer, just in the sense of Sentinel data. So this is just a little bit of information about the advanced search, and there are a number of different ways that you can use that advanced search technique on this Copernicus interface to allow you to really specify what data you're interested in collecting. And you can see here that there are other important parameters that are available within this advanced search window, including product type and sensor mode. So here you can actually choose regions of interest of a box or a polygon to choose the specific location of interest to gather that data that you would like to use from the Sentinel data set. And but really the biggest important thing for us to do is to log in or sign up, because that is basically just like the USGS Earth Explorer, allowing us to have access to collecting the data that we're interested in. So then after you log in or sign up, you'll have to register if you haven't logged in before, if this is your first time and you're signing up. After your registration, and you get a successful registration, you can begin selecting the data that you're interested in. In our case, we will select the two that are previously mentioned, the two data sets that we're interested in. We can click Add the product to the cart, and after you've added it to the cart, then you can begin to gather all the data that you're interested in. So here you can see that offline status that I previously mentioned, and that we need that offline status to then become the online status. And to do that, you need to add the data to the cart and then allow it to become online and available to us, so then we can download it following that. And this process can take anywhere from 5 minutes to a couple of hours, so it's kind of frustrating if you're really trying to go on the go to grab that data, because as we know, Earth Explorer allows us to grab it really quickly, but with this Copernicus interface, it doesn't necessarily let us get access to the data as quickly as we might like to. So here is what we're looking for, that green check mark to say that the offline product is now being pulled back online and available to us. After that has been become available to us, we can simply just click the download button or the add to cart and process it, so then we can get it onto our computer. But after that, now we're going to dive into some of the techniques of generating this DEM after we've gathered the Copernicus set that we're interested in, our Sentinel data. So this workflow here just shows us what we're going to be doing today. We're looking to prepare our data set by opening a project, co-registering the two different data sets that we have, and then we're going to basically deburst, and then we're going to run it all the way through to either go to a DEM or deformation. And today we're really interested in the DEM, so we're going to be utilizing phase unwrapping and geometric correction techniques to generate a DEM for us rather than the deformation, which is another technique that you can use and another technique that will allow you to see your data in a different view. So before we actually start generating this DEM, we have to add the Snapoo plugin. And so you can see that the Snapoo plugin was created by Stanford individuals that created this open source add-on for us to add in within the Snap software. So if we follow this link here, it can help us get to exactly where we need to go to download the Snapoo plugin. So now that we've installed the Snap application and we've gathered our data, we can head back into the Snap application. And now that we've installed the Snapoo plugin, we need to install it within the Snap software to ensure that it's actually going to be working effectively. So to do that, we're going to head to the Snap interface now, and we're going to select Tools and Plugin. And within Plugins, we're going to just navigate around a little bit. So you can see here that after we've selected Plugin, we need to select the available plugin and navigate to the Snapoo unwrapping because we need to unwrap it. After we've selected the Snapoo unwrapping, we're then going to click Install. Then we're going to click Next. We can click Restart Now and finish it to allow the Snapoo plugin to be installed within Snap. And the Snap software will then restart and then open back up for us. So now that we've installed the Snapoo, we've unwrapped it, now we need to make sure that it's actually available and bundled in for us. So you can see here we navigate again to Tools. We need to click Manage External Tools because now that we've already entered Snapoo, so now it's kind of flagged for us. As you can see in number 3, we're just going to click the Snapoo unwrapping, and then we're going to click this Notepad button, which will allow us to open this large image to our right, which will allow us to select bundled binaries, our windowed bundle, and we need to tell the target folder to go exactly where everything else that we've selected to go into, the Snap folder in our either C or D drive, and then we're going to click Download and Install Now. After it's installed, we get this information image that says the bundle was installed, so then we click OK, and then of course we click OK again to wrap up everything for our Snapoo. So since we've downloaded the data, now we need to get the data opened within the Snap software. So to do that, we do not want to unzip our data that we've downloaded. We want to leave it zipped, and we just want to select both of them and click Open. After selecting Open, now our data is within the software, but we can't necessarily view it because there are a number of different things within that zipped folder. So we're going to select the intensity of either image just to have a visualization. The intensity IWI double V here. This allows us to view our different bursts, as you can see in this image here. Our 9 different bursts on our one data set, our one image that we're interested in viewing. Now that our data is input into the Snap application, we want to see the quality of the data and see this correlation between the two images. So to do this, we're going to navigate to the radar, the interferometric tool within the radar box, and then heading over into the Instar Stack overview, which will allow us to get to this image on our right to check the differences in our two images. So since we're interested in the phase difference of the acquisitions, we're now going to generate a stack containing both products so then we can compare the two different images. And to do this, we're going to be using the co-registration function. So navigating to our radar again, our Sentinel-1 tops this time, and selecting Sentinel-1 tops or S1 tops split. Then within that split area, we're going to go to the I-O parameters, and we're going to name the directory. We're going to tell exactly where we want the output to go, which is, of course, where everything else has been going into the Snap folder. Within that Snap folder right now, you can see we're going to actually create another folder called Tutorial Output, and that's where this co-registration split can go. After we do that, within the I-O parameters section, we're going to head to the processing parameters and select subswap IW2, and then our polarization, we're going to click double V here. With our bursts, this is important. We need to have our bursts to be overlapped. So here we're going to choose 3 to 5 on our first, and you're going to repeat this process for our second data or our second image, and there you're going to select 1 to 3 for their bursts. So the orbit information of both images has already been previously gathered, but now we're just going to assign the orbit files because we already have that data collected. So you can see here we're going to navigate back to the radar again, and within radar we're going to select apply orbit file this time, and then in the I-O parameters we're actually going to leave everything exactly as it is. We're going to go default here, but we just need to tell in the directory where to navigate to. And then after that, we're going to run. But before we click run, we want to tell it to do not fail if new orbit file is not found, so then we can actually generate it exactly what we're needing to. We're going to repeat this exact process for both of the different images. So now that we've given the orbit information, we're now going to back geocode, which allows both of our images that are now have their orbit information to be combined with each other, and it's going to co-register the two different products together. So to do that, we're going to stack the two images by going to radar, co-registration, and then we're going to navigate to S1 tops co-registration. Then we're going to select the S-1 back geocoding. Within the back geocoding, we're going to select add, and we're going to add both of our different swaths that we're interested in, both of our different S1B and S1A. After we've added both of them, we're going to navigate back to the back geocoding, and we're going to select the SRTM 1sec HGT, which is the auto downloaded for the digital elevation model, and then we're going to click run. So sure, we've co-registered, but we want to ensure that the quality of the co-registration is exactly what we're looking for. So to do that, we're going to run the S1 enhanced spectral diversity operator by going to radar again, configuration, S-1 or S1 tops co-registration again, but this time we're going to select S-1 enhanced spectral diversity. Again, we're going to keep everything the same in our parameters, but this time, of course, we have to assign the directory as usual, telling it to go to the snap folder. But then within our processing parameters, we're also going to leave those exactly as they are. We're going to leave them default and then click the run button. After that, we're going to have an output now of the stacked co-registered S-1 enhanced spectral diversity images. So now that we've co-registered the images and stacked them, we want to make sure that they're actually good and that our images, our new image that we've generated is up to par. So to do that, we want to select the specific stack that we've already generated. We want to right-click it, and we're going to select Open RGB Image Window. And here you're going to assign two of the different bands, the red and the green, into one of the two bands. So the one date, for our case, you can choose either the July 2nd or the July 8th. It doesn't really matter. But then the last color, the last band, or the last blue visualization needs to be the other image that we didn't select. After that, you're going to click OK, and then you want to zoom in. And there you want to see visually what that looks like. And so you want to look between different borders. So for example, land and water here, we can see that there is a pretty good differentiation between those two. So in this image in our PowerPoint, you can see that there's a successful co-registration because there's not very much haze, or it doesn't necessarily look like a three-dimensional image. It looks like it's a pretty 2D image, which is exactly what we're looking for. So now that we've verified that our co-registered and stacked image is good enough for what we're interested in doing, we're going to be generating an interferogram. And to do that, we're going to head to the radar tool. We're going to go to interferometric. We're going to go to products and then interferogram formation. There we're going to keep everything the exact same, but we want to make sure that our directory is established. And then we're going to click run, and this will be generating our interferogram. So as we've talked about in the past, in the very early beginning when we talked about the subswaths and the smaller bands within a swath, we can see on the top image toward the bottom of our page, the before deburst, that there are still these large lines in between of the different subswaths. So to eliminate the large gaps between these, we want to deburst. And so to deburst, we're going to head to the radar tool. Again, going to Sentinel-1 tops, and then S-1 tops deburst. And we're going to leave everything the same. Of course, we need to let the directory know exactly where we want this to be saved. But this is really just to eliminate those gaps, these strips that we still saw and we still do see. So that's what debursting is going to do. So of course, after we've kept the default settings, we're going to click Run. So now that we've removed the strips on our image, we can now basically remove noise by using filtering. And so the filtering we're going to be using is the Goldstein phase filtering. So to do that, we're going to head to the radar, the interferometric, filtering, and then Goldstein filtering, Goldstein phase filtering. After we select the Goldstein phase filtering, we're going to keep everything as default and then click Run. And you can see in our presentation here, before filtering versus after filtering, some of those areas of noise have been eliminated, and we have a much clearer image. So since we've done a lot of this processing on our interferogram, we might have actually generated some empty pixels at the edge of our interferogram. And so to eliminate these empty pixels, we're going to do a subset. We're going to create a subset similar to what we've done in Envy in the past. And so to do that, we're going to navigate to raster tool this time rather than radar. We're going to select subset. Then we're going to click spatial subset and assign the following pixel coordinates. At scene start X, we're going to go to 1000, then scene start Y, we're going to select 50, scene end X, we're going to select 25,000, scene end Y, we're going to select 2750. After we've selected these different pixel coordinates, we're going to select OK, and then we're going to go back into the area that we can see all of our data, our product explorer, and then we're going to right click after we've selected this subset of the area, and then we're going to save the product. And as you can see here, we have a new product that's shown within it, but now we need to permanently save it because it's only a temporary product. So to do that, we're going to click the Save Product and go through the process, saving it into the exact same location, that snap folder in either the C or D drive, which will then allow us to have a subset of our original interferogram, which will be much clearer because it's removed some of those possible empty pixels at the edge of our data set. So this is the next step that's not necessarily crucial, but it allows us to correct slant range geometry to ground range geometry called multi-looking. And so to do this multi-looking, we're actually going to head to the radar this time again, going to SAR utilities and selecting multi-looking. Of course, we're going to leave everything as it is. We're going to leave all our default settings. We're going to tell our directory where to save this multi-looking, and then we're going to click the Run to get our output. So now we're going to be phase unwrapping. We're going to be unwrapping in Snap to generate our DEM. And so to do this, we're going to head to the radar again, going to interferometric. We're going to do unwrapping and then click SnapU export. This is important because the SnapU plugin is going to allow us to unwrap, and then we're going to be able to re-import the unwrapped phase that we generate through SnapU back into Snap for viewing. So after we've selected the SnapU export, we're going to just make sure that we tell what target folder we're going to go to on the SnapU export section. And then we're going to click Run, of course. We're just going to, it's going to generate a folder, and we can call that folder unwrap, and then we're going to say that this is the DEM that we're going to be creating. So now that we've created this export of a wrapped phase, we're going to be going to the unwrapping part using the SnapU plugin. So we go to Radar, Interferometric, Unwrapping, but this time we're going to select SnapU Unwrapping. And to do this, we're going to use the wrap phase generated from SnapU as the input. And then we're going to basically allow it to run. So we're going to, as long as we select display execution output and tell the output folder where we want it to go, of course, the C drive or the D drive that we've previously been selecting into the SnapBoo tutorial output folder. And then we click run. It's going to take quite a bit of time to run, to unwrap. And then after it's unwrapped, we will then be able to select the OK to see this output product that will automatically be opened within Snap. But that product that we have isn't exactly what we need because, again, we have to import the unwrapped phase back into Snap. So we're actually going to close the product, and we're going to say that we do want to save it, but we do not want to save the product to be converted. So you'll select no after you select do you want to save it? Yes, and then select no to being converted. Now this is that third component of the importing the unwrapped phase back into Snap after we've used SnapBoo to unwrap. So to do this, we're going to head back to Radar, Interferometric, select Unwrapping, and then click SnapBoo Import. Here we're going to basically just go to the read phase, and then we're going to basically select exactly what we're looking for, that unwrapped phase that we generated within the SnapBoo plugin that we've previously just did a couple slides ago. For the first read phase, we're going to select the unwrapped phase, but then for the to read unwrapped phase, we're going to select that subset that we previously have generated. Then for our SnapBoo import, we're going to just uncheck the do not save. And then for our for write, we're going to direct it exactly where we want it to go, and back into that Snap folder, that tutorial output folder if you've been using it. And then you'll click run, and then you want to say yes to overwriting. So after we've unwrapped it, we are now going to be seeing exactly what we see on the bottom right of our screen, which is what we're looking for, which is the phase after the unwrapping process, which allows us to now start to evaluate some of our data as previously with before the unwrapping, which is where we did all of our different editings to make sure that our data was going to be as clear and crystal beautiful as we're looking for. So now that we have this unwrapped phase, we want to now change the phase to an elevation view. So we're going to go to Radar, we're going to select Interferometric, then we're going to select Products. There we're going to select Phase to Elevation. After that, we're going to go and click within the Phase to Elevation DEM generation. We're going to basically leave everything the same. We're just going to specify under processing parameters the digital elevation model needs to be selected to be saying SRTM1SEC HGT, and then we're going to click the run. After we run, it should be displayed, and we can actually now see our elevation model. So now that we've created this elevation elevation map, we want to do a final geocoding and terrain correction to make sure that it's actually projected true to the landscape. So to do this, we're going to head back to Radar, Geometric. This time we're going to select Terrain Correction, and then we're going to click the Range Doppler Terrain Correction selection. And then we're going to specify exactly where we want our output to be, which is of course that C or D drive that we've been utilizing. And then we want to change the following things to exactly as I state here. Our digital elevation model should say SRTM1SEC HGT, which is auto download. The DEM should say bilinear interpolation. So should the image resampling method. This pixel spacing should say 14.67. Our pixel spacing DEG should be 1.3178, etc. Our map projection should be our WGS84DD. Then we're going to select mask out areas without elevation. And then for our output bands, we want to select source band and DEM. Then we're going to select run, and we'll have our elevation with our true projection shown within our Snap view. And then if we're interested in comparing all that we've done now, this DEM that we've generated, we can take it to Google Earth by a number of different ways. A simple way that you could do is going to File, Export, Other, View as Google Earth KMZ, because the KMZ file is exactly what we need in order to effectively view it within Google Earth. And then after we click save in the specific location that we're interested in, it's going to save that KMZ, and then we can open Google Earth and view the location of the elevation patterns on a satellite image base map. So then we can do some comparisons between this DEM that we just generated using radar sat data to satellite imagery, the optical imagery from Google Earth or Google or ArcGIS if you're interested. And with that, I hope this helps you generating a DEM utilizing the Snap application and the Snapu add-on to utilize RadarSat data from the Copernicus downloading site. Have a great one.